Good day, class. My topic is stereochemistry, naming isomers with CIP to assign R and S or R or S prefix. Include a minimum of 5 examples. Now, when we covered this in the class, what I had a hard time was when I went down the line of atoms and trying to assign priorities. Sometimes, well, especially when there's substituents and there was branches, I got confused at times, and it was helpful for me to draw a condensed formula drawing of it to help me visualize what atoms were attached. Before I go over the examples, briefly cover over the rules of assigning priorities. In the textbook, the first rule was you assign priorities in order of decreasing atomic number. The highest atomic number will get the highest priority. When you have atoms that are the same, then you would go off of the atomic number bonded to that atom. So now to backtrack a little bit, these are for chiral molecules. You're looking at carbon with 4 different groups. So you're looking at 4 different groups. So you say you have 2 carbons and one of them was just a carbon chain. So it was just like one carbon, like a butane. And then the other one had an oxygen bonded to it. Now you look at the bonded atoms, and so since that one had an oxygen, that's a higher atomic mass, atomic number, so that would get a higher priority. When you have 2 isotopes, the priority goes in order of decrease in mass number, so the higher mass number will get the higher priority. And when you have multiple bonds, which is double or triple bonds, then you would count that atom twice. So if you had a double bond to an oxygen, you would count that twice as 2 oxygens bonded when assigned priority. The steps to assign the R or S configuration is first you would assign the priorities, then you would orient the lowest priority to the back, which on the textbook or paper that would be a dash wedged. And then you would trace priorities clockwise if the number 1 to number 2 and number 3 priorities in the clockwise rotation, and then so you would assign an R. Otherwise, if it's a counterclockwise, it would assign an S. Keep in mind that this is only applied to the highest priority. The lowest priority is into the plane, which is a dash wedged. Here is the first example. As you see, we have a 6 carbon chain, so that's a pentane. And then at the number 3 carbon, we have an alcohol group, an OH, and a hydrogen. Now the hydrogen, to assign priorities, you have the OH, since that is an oxygen, that gets the highest priority. Now on the pentane, it goes in 2 directions, and so it's a string of carbons. If you look on the left, so 4, 5, 6, you have 3 carbons there, while the 2 and 1, you have 2 carbons. Since the one with the 3 carbons will have a higher priority, since at the second carbon you have another carbon versus if you went the other way, you would have 3 hydrogens. And so that would get the number 2 priority. And going next is 3 priority is the other side of that carbon chain. Since the hydrogen is already facing the backwards, we are doing a counterclockwise rotation, and so we have an S configuration. So the name for this molecule would be S-pentane 3-ol. The next example, we have a cyclohexane, and we have 2 substituents. We have a fluorine and a bromine right next to each other. So with them being next to each other and bromine being the first alphabet, that will get the number 1 carbon, fluoro will get the number 2 carbon, and then that's how the carbons will be numbered. Now starting with the fluorine, fluorine would be the highest priority. There is a hydrogen attached to it. And going in the direction to bromine would be the second priority, since going either direction on that ring would hit a carbon. But if you go counterclockwise or clockwise direction, that carbon will have a bromine to it, which would be the number 2 carbon numbered. Or sorry, the number 1 numbered. So in that case, the number 1 probably the fluoro, number 2 would be going down, and then number 3 would be the other direction on that ring, and so that will be a clockwise rotation. Since fluorine is going out of the page, we know the hydrogen is going into the page, so that's behind the plane, and so that's a clockwise, and that will be assigned an R. And similarly with bromine, same priority numbering. So bromine with number 1 going in the other direction on that ring. So going to the number 2 carbon number to the fluorine, that would be the second priority. And the third priority would go in the other direction on that ring. And like fluorine, you have a hydrogen but not drawn, but it's behind the plane. And so with that priority, we have a counterclockwise rotation, and so that would be an S. So the name of this molecule would be 1S, 2R, 1 bromo, 2 fluoro, cyclohexane. For our third example, we have an 8 carbon chain, and numbering from the right to the left, we have at the number 4 carbon, we have a ethyl group, and at the number 5 carbon, we also have an ethyl group. So starting at carbon number 4, we see that the ethyl group is going into the plane. So that is opposite. So when we assign the letters, we're doing the opposites. So the number 1 priority will be going down the carbon train first. So at number 5 carbon, since number 5 carbon has 2 carbons attached to it, that will get the highest priority. The second priority would be attached to the going towards number 3 carbon, since there are 3 carbons going that direction, while the substituent, the ethyl group, that has 2 carbons. So 3 is more than 2, and so the priority rotation will be clockwise, but since the hydrogen, the lowest priority, is coming out of the plane, we would assign a S to that. Looking at number 5 carbon, we see that using the same methodology as we used before, the number 1 priority would be going to number 4 carbon. The second priority would be going further down the carbon chain, so that's going into carbon 6. And then the third priority would be the ethyl group. With that priority, we have a clockwise rotation, and so we would assign a R to that. The name for this molecule is 4S, 5R, 4,5 diethyl octane. For our fourth example, we have a 10 carbon chain, and looking at the number 3 carbon, we have a hydrogen that's going into the plane, a methyl group going out of the plane, and so the priority would be looking at carbon 4 and 5, then 6. We see at number 6 there's another carbon attached to it, but the other 2s, so that would have the highest priority. Going to number 1 to the number 2 carbon, we see we have 2 carbons there, which is more than a single carbon at the methyl substituent, so that would get priority 2. And so going from carbon number 4 to carbon number 2 and then the substituent group, we have a counterclockwise rotation, so we have an S configuration. Looking at carbon 6, we see that the substituents, we have an isopropyl group, and so since that first carbon going out on that substituent group has 2 carbons bonded to it, versus if we look at the other 2, if we look at the carbon chain, they're looking at the carbon chain, so looking at carbon number 5, we go to, at carbon 5, we only have a single carbon versus substituent has 2 carbons attached to it, and so that has a higher priority. Looking at carbon 7, same situation, so we will go further down the chain. So going back to carbon number 5, At carbon 3, we have another carbon attached to it, so that's 1, 2, 3 carbons. The other direction, the third carbon going down only has a single carbon. So going to carbon number 5, we'll have a second priority. We have a counterclockwise, and the low priority is going into the plane, so that's an S configuration. And this molecule is 3s 6s 6 isopropyl 3 methyl decane. And for our last example, we have a 10 carbon chain, and the number starts from the left since we have a number of substitute number 4, number 5, and number 7, which give us lower numbers if we went the opposite directions. Starting at number 4 carbon, we see that if we went to the number 5 carbon direction, we have a substituent group, and so number 5 has 2 other carbons attached to it, while the others do not. If we went to the number 3 carbon direction, we have 3 carbons there, so at this number 3 carbon we have another carbon attached to it, and if we looked at the wedge, which is just a methyl group, it just has hydrogens bonded to it, so that's a low third priority. There is a carbon there, and that's the 4th priority, and that's into the plane. And so going in the priority direction, we have a clockwise rotation. The lowest priority is into the plane, and so we have an R configuration. Looking at number 5 carbon, we have a chiral group. Going into the number 4 carbon directions, we see the number 4 carbon has 2 carbons attached to it, which if we look at the substituent group, the dashed line has 1 carbon. The next carbon in that direction only has a single carbon, and so the number 4 carbon has higher priority. And if we look at the other direction, that is the same case, and so the number 6 carbon only has a single carbon. Going to number 7, we see we have 2 other carbons attached to it. And there's a change to number 8, number 9, and number 10 carbons, while the substituent group at number 5 carbon just has 2 carbons attached to it, and it ended. And so the number 1 priority would be going to number 4 carbon direction. The second priority would be going to carbon number 6, and the third priority would be the substituent group. There's a hydrogen which is coming out of the plane towards us, so it's a wedge, and so our rotation of priority is clockwise, but since the lowest priority is coming at us out of the plane, it is the opposite, so it's an S configuration. And looking at number 7 carbon, we see that there's a methyl group substituent, so compared to the other ones, we see that's be the number 3rd priority. Going to carbon number 6 direction, we see that when we hit carbon number 5, we have 2 carbons attached to it, and if we went into carbon number 8 direction, we see it's just a single alkane chain, and so there's only single carbons bonded to it, and so the number 1 priority would be going to carbon number 6. Going to carbon number 8, that would be the 2nd priority, and the substituent group at carbon number 7 would be the 3rd priority. And that is a clockwise rotation, and so that's an R configuration. And this molecule name is 4R 5S 7R 5 isobutyl 36 dimethyl decane.